got a series of talks on more specialised anonymisation topics this afternoon. And part of this is thinking about connections with tomorrow. Some of it is to do with thinking about different types of data, new types of data, and different sorts of problems they throw up. And they're definitely thinking about, as we move forward into the future, what are the additional considerations that we're going to have to take into account. Our first speaker is Hiroaki Kikuchi, have I said that right? Okay, thank you. He's going to talk to us about data anonymisation and quantifying risk competition.
Okay, thank you very much for Mark Elliott for introducing me and also for giving me a chance to talk to this in front of so many audience. I'm Hiroaki Kikuchi, coming from Japan, and going to talk about the data anonymization competition, which was happened in Japan. Let me introduce a little bit about myself. I've been working on the information securities and being involved to the data anonymization for 3 years ago. And then at that time, I was a chance to organize the data anonymization competitions. So let me begin with some background of our researches. What is the difficulties in data anonymization? We have the couple of the problems. First one, we don't have the real data sets. Data owners don't want to publish their confidential data sets. Therefore, the researchers choose their favorite data sets so that they can get some better results for their models. Sometimes we have no standard matrix for quantifying the risk. For example, depending on the risk, depending on the models, risk can be modified a little bit. So therefore, which makes me a little bit difficult to quantify the difficulty of quantify the risk in these models. And actually, the last one is more serious. We don't have no standard model of the adversaries. And sometimes people mention that mildly motivated adversary is better than the highly motivated adversary, something like that. So in order to address these problems, we have held data anonymization competitions, which was happened in the Japanese domestic conference, the PWS Cup. That stands for Privacy Workshop, which was organized by Japanese Information Processing Societies and also supported by Japanese privacy commissioners. And the first one was held in the 2015 in Nagasaki. And this year, we have the second one in Akita. Also, Professor Joseph Domingo participated this one to give the keynote talks. And the previous years, we have the 13 teams join these competitions. And this year, we have the more than 15 teams and the total of the 42 researchers join our games. And also, we have the several data sets. The last year, we have the synthesized data sets, which was which was generated by the Japanese government. And this year, we have the real data set, which is available from UCI data mining repositories. And this is the picture posters for promoting our competitions. And like that, we have some the offense and the defense. Defensing to protect the data privacy, offensing trying to re-identify the data privacy against them. So according to this type of the games, we want to establish more reliable, more practical data anonymization technologies for them. So in order, according to the difficulties, we have them. Here is our approaches. We have the two common data sets to anonymize and also to quantifying the risk. And also, in order to qualify the utility and also securities, we have some baseline of the utility functions and also some sample re-identification algorithms. And also, the party are encouraged to use their own developed technology, their own developed identification algorithm to attack the other anonymized data. And we adapt as the adversary model as proposed by the Joseph's maximum knowledge attacker models. Okay, here is the data set we use for this year's online retail data set, which is available from the UCI machine learning repositories. And this is consists of the 1 year true online transactions taken to 2010 from the United Kingdom's online retail shops. I guess it's a .com gift shop or something. And also, it contains more than 500,000 records per year. However, this record somehow noisy. For example, some data is inconsistent, sometimes missing the country or something. Therefore, we perform some cleansing and choose a small subset of the data set. And here is our statistical data of our data sets. We divide the data set into the two tables. One is the customer master data, M, and the other is the transaction for each payment record, T. And for two tables, and what linked together by the customer identities for each other. And these are true. These came from the online retail data set. However, only the attributes of the sex and the birthdays are synthesized at randoms. And also, you see here is the customer identity 1000. Anyway, he is invoice ID, date, time, and the stock code, which means the kind of the goods, and also price and quantity like that. And you see this true identity is linked to two different records in transaction T's. And what kind of the privacy threat among these data anonymization models? And here is the table of the, as I mentioned, M and T, and these personal data can be anonymized like this. The names is replaced by the pseudonyms. The data might be generalized like this. However, as you see, we have the re-identification risk based on the data, anonymized data, trying to guess whose data it is. And second one is the record linkage risk. And looking here, we may notice that these two records belong to the same person because the same identity. Therefore, the adversary can easily link between two different records. And the third problem to estimate from the generalized data to true ones. And the fourth one is somehow to sending to the adversary messages to the true data owners. And last one to the reference to the other data resources. According to new regulation in Japan, not all of these threats are illegal. From our new regulations, only number 1 and number 5 are dealt with. And our new regulation does not care about number 2 and number 3 and number 4. Therefore, we focus only this risk to be our games. So this is the games we designed. So we have the two tables, M and T, which was a little bit simplified. And the two players, first of all, data anonymization parties trying to modify this data, M to M prime, T to T primes. Sometimes they may replace pseudonyms by the true customer identity and also modify the countries so that type of the K anonymity can be satisfied like that. And also in these processes, new pseudonyms are different to the true identity. Therefore, they may some sort of permute the order of the record like this. So we call this is the record indexes. So the data adversary trying to guess the true permutation given these two M and T. So like this. And also, for this case, the score can be computed on this formula, simple formula, which is number of correctly estimated record, like this, 3 and 2. Maybe they may guess based on these informations. And this is the score for the data anonymization parties. So how to estimate the data? The party, the identification party, are allowed to have access to original data sets. Therefore, this is the maximum knowledge, we say. And they output to the estimated index Q. Okay, and here is three use cases for our purposes. Number one is RF analysis, recency frequency monitoring. Based on these quantities, we may classify the set of the customers. And corresponding to this use case, we define the utility 3. And also, the other is association rule minings and cross tabulations. For each of the use cases, we have the simple utility function for this. And also, here is the re-identification algorithm from the E1 to E13. For example, re-birthday, PY, which is implemented by the Python, and just to find the shortest birthday from the M and T's. And among these re-identification processes, I just mentioned only the E7 because this is the highest accuracy. And this is a simple algorithm. We just compute number of the payment record for each of the customers. For example, in this case, he paid 2 times per year. Therefore, his number of the records is 2. So based on these quantities, we may sort the number of the customer identity and the pseudonyms, and trying to guess whose data it is. And this is the highest. Okay, here is the competition rules. Each team submits the anonymization just once, and reject cheating. I mentioned before, I mentioned later, and each team is allowed to de-identify the party, okay? And the winner is determined by the grade defined by U plus E. U is the minimum of the utility, and E is the minimum of the securities. And also, and what is the cheating? The best anonymization algorithm is do nothing, which means, and if M prime is going to be equal to M, and just send to the wrong permutation matrix. And then it can have the highest utility, however, no one can guess his true identity. So this is the cheating problem. So in order to detect these problems, we have some condition for cheating detections using the permutation one. Okay, and this is the website we have developed, and the people just prepare for the data anonymization. Just copy and paste on this website, which can automatically compute the utility and also securities like this. And here is a snapshot of our competitions. Many people enjoy, though I don't know, but anyway, they can participate very hard. And finally, some teams from the university will won the first prize this year. Here is the competition results. You see, this morning I mentioned that the utility and the risk map like this. And you can see that there is a trade-off between the utility and the security like that. However, some teams might be beyond these ones. And finally, this is the finalist, the winners. Okay, I may skip some of these. Let me conclude my talk. We have proposed the data anonymization competitions, and average re-identification ratio is 47% out of the 400 customers. And also, if you may interest about our results, the last year competition has been published on some lecture note on the IEEE conferences. And we plan to do the international version of our competitions. And I'm happy if some of you are interested about to help us, and we are really appreciated for this. Thank you very much.
Thank you very much. Any questions? Okay, I've got a question then. So the utility function that so was that hidden from the participants?
Yeah, utility functions are available to every participant,
Right. Okay.
including the source code.
Okay. So they can engineer their solution so they maximize the utility across those functions, which may be arbitrary. So it's one of the things we actually carrying out a similar challenge. We're just piloting the system now for synthetic data. And one of the things we were deliberating was whether to hide the utility function, because that's realistically the situation you're in as an anonymizer. And what we ended up doing is actually we have everybody is allowed to submit one utility function into the pool, but they're ignorant of everyone else's, so they can optimize on their own, but they don't know what everybody else has submitted. Any other questions? Yeah.
Excuse me, could you tell how the trade-off curve was obtained? So,
Trade-off?
at the end you shown a trade-off curve between the utility and anonymization. So how this obtained then?
You mean this?
Yeah.
Yeah, we don't compute any approximation of this. Just to looking here, there's a roughly relationship between the utility and the securities. There is no mathematical model for this, because it's really hard to predict the behavior of the adversaries, because they are allowed to their own algorithm to attack somebody. Yes.
Okay, any others? All right. Well, thank you very much.
Thank you very much.